We spend something like 25 years of our lives asleep. And for a good chunk of that time, our minds are just running wild. So today, we're going to dive into what's really going on when we dream.
Okay, let's just get right to it. The one question we've all asked, probably after waking up in a total panic, right? Why are dreams just so bizarre? I mean, one minute you're frying, the next you're at your old high school taking a math test you didn't study for. Like, what is the point of all that chaos?
Well, for the longest time, the answers we had were totally split. You had two camps. In one corner, you've got the biologist saying dreams are just meaningless, random brain noise, pure static. And in the other corner, you've got the psychologists arguing that no, dreams are these rich, symbolic messages from deep in our subconscious. I mean, these two ideas could not be more different.
But what if they were both right? There's this incredible new framework called the Integrated Survival Simulation Model, and it finally connects these two totally opposite ideas. The big idea here is that dreaming isn't just random noise, and it's not just a story either. It's actually a whole process that starts with pure biology and ends up with this powerful, high-tech survival simulation. So how does this all work? How does it actually happen? Well, it all kicks off with a simple biological spark. You can think of it like your computer powering up for its nightly maintenance check. It's this basic, absolutely essential first step. Okay, so at the very heart of this is something called the defensive activation theory. And the idea here is, well, it's pretty wild. Your brain is literally defending itself. See, during sleep, your brainstem zaps these little electrical signals to your visual cortex. But here's the kicker. The reason it does this, at first, has nothing to do with creating dreams. It's all about protecting its own turf.
Let me break down how this defense system works. First, you close your eyes. So your visual cortex goes dark, no input. Second, and this is key, your brain is super competitive. It works on a strict use it or lose it basis. If a part of the brain goes quiet, other senses like hearing or touch might actually try to move in and take over that neural real estate. So to stop this from happening, the brainstem defensively fires off these powerful electrical signals. They're called PGO waves, just to keep the visual cortex busy. And that right there, that's the raw energy that's going to fuel the whole dream. All right, so we've got this raw, totally random electrical energy just firing away in the brain. But how does that static turn into, a world? Well, that brings us to the next stage, building the dream world. It's like we're loading the environment for the simulation. You might not realize it, but even when you're awake right now, your brain is constantly running an internal simulation of the world. It's like a predictive model that's always trying to figure out what's going to happen next. And here's the crucial part, that amazing engine, it doesn't just turn off when you fall asleep. Nope, it just keeps on running. So when you're asleep, there's a part of your brain called the thalamus, and it basically acts like a bouncer at a club, blocking almost all the sensory input from the outside world. That gate is shut. But on the inside, your internal model of who you are and where you are, that just keeps on going. And the simulation engine, it captures those defensive sparks we talked about from the brainstem. It takes that internal noise and treats it like it's real sensory input. And that is what creates the vivid, totally hallucinatory landscape of your dream. Okay, so now we've got this rich, crazy, hallucinatory world that's been built from nothing more than random biological noise. But here's the thing. It's not just some random movie playing in your head. It actually has a purpose. This is the survival mission. This is the actual program the simulation is designed to run. And this is where something called threat simulation theory comes into play. The idea is that the brain uses this bizarre, internally generated world as a kind of perfect, totally risk-free virtual reality. It's a training ground, a place to practice and sharpen your responses to all kinds of potential threats, everything from physical dangers to really complex social conflicts. And your brain isn't just passively watching all this unfold. No way. The higher parts of your cortex are actively trying to make sense of all those random signals, to synthesize them. But it's not just making up any old story. It's steering all that chaos toward one specific goal, survival. It becomes this perfect rehearsal space for fight or flight moments and a sandbox for working through tricky social problems. Right. So once the simulation is over, the brain's job still isn't finished. It has to process everything it just learned. And that brings us to what we can call the narrative payoff. This is the part where all that messy, chaotic data gets neatly organized. And this happens in two really important steps. First up is narrative construction.
The brain takes that wild simulation and wraps it up in a story, because, let's face it, that's the best way for us to make sense of anything. Then, step 2 is memory consolidation. The brain looks back at the simulation, it analyzes the outcome, and it tags any useful strategies or ideas for long-term storage. And everything else, it just gets tossed out. It's an incredibly efficient sorting process.
So, what's the actual real-world benefit of this whole incredibly complex thing your brain does every night? Well, it's a massive cognitive payoff. Seriously, you can think of it like getting a free, automatic software upgrade for your brain every single night.
This process really delivers 3 major upgrades. First, you get better memory consolidation. Second, you get better at organizing your experiences into stories that make sense. And third, and this one might be the coolest of all, you get a huge boost in creative problem solving.
And this is where things get truly amazing, because the dream simulation is built from the bottom up. It's built on pure randomness. It isn't tied down by logic or the rules of reality. This means it can explore what researchers actually call illegal connections between ideas. Links your logical, awake brain would just immediately shut down. This is the engine of our aha moments. It's where we find those completely unconventional solutions to problems we've been stuck on for ages.
There's a quote from the research that just puts it perfectly. It says, "A dream isn't just a glitch. It's a comprehensive system diagnostic and optimization routine." In other words, it's the process that keeps both your brain's hardware and your mind's software running at absolute peak performance. So the next time you wake up from some crazy, weird dream, don't just brush it off. Remember that your brain was actually hard at work running this super sophisticated maintenance and training program just for you. Which, of course, leaves us with one last question to chew on. What survival skills will your brain be practicing tonight?